Hey folks, welcome back. And in this lecture, we are going to continue module number 3. This is module 3, part 2, where we've been talking about computational thinking. In this lecture, we're going to pick up from where we left off last time, and we're going to talk more about drawing using turtle graphics or the Artie robot. So in the last lecture, the very end of the lecture, you guys wrote the following thing in a replet, which was import turtle, t equals turtle turtle, and then t dot forward parentheses 100. And when we did that, we saw that what we got in our output window over here on the right was a straight line that was 100 long, however long 100 is. And so that's the very beginning of turtle drawing. And the same would have worked in the Artie robot. I'm going to show you specifically how to do that in just a few moments. So let's talk about some other stuff that we could do. Look, first off, what we have done already is we have programmed. The fact that you drew a line, I know was very simple, it was one command, but you told the computer, I need you to draw a line that is 100 long. That is a program. Now, the program that you are writing is actually in a language called Python. And in this case, it's specifically Python with Turtle. Turtle is a library that allows you to do this drawing. It's not natively part of Python. So effectively, this is an emulator that's written in Python for a library called Turtle, which is a lot of words. The Turtle library has a few commands. There are actually more than these, and you can go look them up, but these are the commands we're going to use because they're common between the Turtle library and the Artie robot. They both use the exact same commands. So one example, which is the one we've already seen, is t.forward. And as we see, what that did was it told the turtle to move forward 100 spaces and to draw a line effectively. The next command that you're going to see is t.left, and then it takes a number in parentheses. The number 90 in this case is going to tell the turtle to turn left 90 degrees, which is going to have it now pointing exactly straight up if it was pointing straight across. T right 90 tells the turtle to turn right 90, and then we have two more commands, which are t.pen up and t.pen down. Okay, sometimes you're going to want to move the turtle but not actually draw a line. So then you tell it pen up, move the turtle, and then pen down. So basically you have 5 commands. Notice that the first 3 of those commands take a number that goes inside the parentheses. The last 2, there is no number in there. And you might wonder, why is that the case? Well, for pen up and pen down, there's nothing you have to tell it. You just tell it pen up or pen down. So we would say that pen up and pen down don't take any parameters. The first 3, however, you can tell it how much you want to do of each of those. So for forward, the number tells it how far forward you want it to go. For left, tells it the number of degrees that you want it to go left, and likewise for right. So those are called parameters. The details of that are not something that we really need to understand right now. We'll see it again in later languages, but you'll notice that some commands take parameters and some commands don't take parameters. So let's take a look at this. What would the following commands draw? So we're telling the turtle to go forward 100, which we've already seen draws a line. Then we're telling it to turn left 90, go forward 100, turn left 90, go forward 100, and turn left 90 and go forward 100. So what are you going to end up with? Well, let's take a look. So we're going to go forward 100, left 90, and then we're just going to do that over and over again. So very specifically, I'm just going to copy those commands because they are actually the same commands that I'm running again and again, and I'm going to paste them. Oops. It looks like I'm going to paste them 4 times. That last one isn't meant to be there, that last left. So I think that's the same thing. Forward, left, forward, left, forward, left, forward. So 4 forwards, 3 lefts. Yep, same commands. All right, so let's run it. What do we think we're going to get? Well, it'll go forward, it'll turn left and then go forward, it'll turn left and go forward, it'll turn left and go forward. And after you do that, you should end up with a square. And there it is. So that's how you can have the turtle draw a square. Pretty exciting. So it's important to understand why you got a square out of that. It's because you told the turtle to go forward and then turn 90 and go forward. Well, that effectively gives you an L, although it's on its side. You then told it to turn left again, and since that's the same direction, it completed a U on its side, and then finally it drew the last part. All right, so based on that, figure out how to draw a pentagon. So when I say figure out, I mean literally pause the video and I want you to, in your own Replit, go figure out how to draw a pentagon. Go. All right. Well, hopefully you have taken a moment to try doing that. I will tell you again, the answers to all of these questions are in the slides. If you click on to the next slide, you're going to see the answer. But you don't want to do that because you're not going to learn anything from doing that. What you instead need to do is actually go try the different things. So if you didn't go try it, please go try it. All right, so the hint here is a pentagon has 5 corners. So if there are 360 degrees in a circle, then that gets you back to the beginning, and you want to have that broken up over 5 points, then you need to divide 360 by 5, which is going to give you about 72. So I believe if I draw a line, turn left 72, 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 and then draw a line, I will end up with a pentagon. Let's see if it worked. And indeed it does. And if you wanted a hexagon, you would divide 360 by 6, which would get you to 60 degrees. And then you would do the same thing there, except you'd have 6 forwards. And so you could see that. And then I just need to paste in one more edge, so I'm going to do the copy and paste trick again. And there we go. It did not copy for some reason. All right. It is refusing to paste. There we go. And so now we should get a pentagon. A hexagon, I mean. All right, part of that went off the screen, so that's not ideal, but it did get us what we needed. All right, so based on that, that's the solution for the pentagon. What happens if you had gone left instead of going right? So we're going to go back to the pentagon, and we're going to put these back to 72. And we're going to get rid of these last 2. Okay, so theoretically that should get us back to the pentagon again. There we go. So the question was, why did I go left? Why not right? What would have happened if I went right? Well, let's see. We're going to change all of these to right, but I want you to ask yourself in your head, what do you expect to happen while I'm typing this? So each one of my turns was left. Now they're all going to be right. So what's going to change in the picture? Am I still getting a pentagon? The answer is yes, I'm still going to get a pentagon. The only thing that's different is it drew it below where I was starting instead of above. And that's because at the end of this first line, I used to tell it to go left, in which case it went this way, and then this way, and then this way, and then this way. But since it's now going right, it goes down, down, back up again. So really, it's just a matter of which side of the pentagon it drew. As a matter of fact, you could put both of them in there, and you could continue on, and you could make all kinds of crazy patterns and shapes out of that. What would happen if I changed all my forwards, instead of being 100 to being 50? Well, again, I'm going to go ahead and do it. While I'm doing it, I want you to think about what you think is going to happen. Am I still going to get a pentagon? Yeah. What's going to be different? It's going to be smaller. All right? And if I were to change it to 500, it would be much bigger. It would actually draw it off the screen if in that case. So the forward and the right allow me to draw pentagon, squares, or anything else. It's just a matter of what I get based on how big the lines are and how far I turn at each point. All right, so next up, I'm going to have you try a few shapes on your own. So try to figure out how to draw an upside down triangle. Again, I literally mean for you to pause the video and go do this right now. So the hint is you're going to have 3 sides, so there's going to be 3 forwards, and in between you're going to need to turn right, it looks like, in order to draw this triangle. How many degrees you need to turn right? Well, it's 360 in a full circle, so you're going to want to do a third of that. I'm going to let you figure that out by yourself. So go do it. All right, so let's take a look at the solution. So we're going to need 3 times where we go forward, turn, and go forward. The 360 divided by 3 is going to be 120. And in the case of this picture, we are trying to go right at this first turn, right? The turtle started off here, and he went this way, and then he had to turn right in order to come down here. So these need to be right-hand turns, and I believe that's going to get me the upside-down triangle. And it does. All right. Well, based on that, you should be able to figure out how to do the other triangle, which is the upward pointing triangle. So again, I want you to pause the video and figure this one out by yourself. Okay, so let's talk about the solution here. Again, you're going to start off, you're going to get to the end of this line, and then you're going to need to turn left instead of turning right. So if you just change all of your rights to left, you should get an upward pointing triangle instead of a downward pointing one. All right, so that's pretty easy. All right, how about an equal sign? So to be clear, I want you to draw a line like this, and then down below it, I want you to draw another one back. Well, in order to do this, you're going to have to tell the turtles to stop drawing lines when it reaches the end, then move the turtle down and get him to draw the other line back. So go ahead and try solving that for yourself. All right, so we're going to give this one a try. So the first thing we're going to do is we're going to go forward 50 and draw a straight line. That's fine. Then I'm going to ask it to take the pen up. So T.pen up. And then I'm going to ask it to turn right 90 degrees. So what I've done so far is I've drawn the first line, and at the end of the line down over here, I've told it to lift the pen and then turn right. Now I need it to go forward. It's not going to be a full 50 because it's about half the distance. So I'm going to tell it to go forward maybe 25. Now note that that forward is not going to actually draw a line. It's just moving me from one point to the other. And I'm going to get rid of all this down below, and we're going to run this for now so that we can see what happens. So you notice that the turtle has left the first line and it didn't draw a connecting line, it just moved down. It's now pointed the wrong way. I need it to point to effectively to its right in order to come back and draw the other line. So I'm going to do a T.right 90, and then I'm going to ask it to do T.forward 50. But this time I do actually want it to draw a line, so before I go forward, I need to do T.pen down. All right, so we should draw a line. We should turn right, go down below it, turn right again, which has us pointing the other direction, and draw a line of the same length. And that got me an equal sign. All right, and our next one is going to be a not equal sign. This one's going to be a little bit more challenging, so you're going to have to think about this one for a few moments. The equal sign you've already done, but I want you to think about how you would draw a diagonal line across it like that, because that's going to take a moment. I will give you a hint. I didn't get this on my very first try. I actually had to play with this one for a few moments to get it right. So again, go ahead and pause the video and see if you can figure it out. Okay, so the important thing to notice is that after you're done drawing the bottom line of the equals, the turtle is currently in this corner and it's pointed this way, right? It's pointed to the left. What I need to do is I need to turn it so that it's pointed south or down, and then I need to go down just a little bit and then get to this weird angle, put the pen back down, and move up in that diagonal angle. So you're pretty much just going to have to do this with trial and error. So the first thing is take up the pen so that you're not drawing a line. We're going to turn left, so T.left 90 degrees, so that we're pointed directly down. All right, so I'm going to run this right now, and this is an important way to do things. Try a little bit and see if you got what you expected. So you can see the turtle is now pointed in the correct direction. So now what I need to do is I need to move forward just a little bit. So T.forward 20 turns out to be the right answer, but I kind of had to play with that for a minute to figure out what was right. And now what I need to do is I need to turn the turtle so that he's pointed in that weird angle up this way. Well, 90 degrees, if I turned, let's say left, 90 degrees left would get me this way, 180 would get me pointed back that way. So it's somewhere between 90 and 180. 145 seems like a reasonable first guess, so let's try that. T.left 145, and then T.forward. I don't really know how far I need to go forward, but we're going to guess maybe 30? Who knows? All right, let's see what we get. Again, this is not something that you're going to know first try. You're going to have to try a few different things. Well, 30 clearly was not enough. The other thing is I'm not actually drawing a line yet. So T dot pen down so that the pen is actually moving. Let's try 100. All right. Okay, well that's not terrible. It's a bit dramatic. Actually doesn't look terrible at all, but we probably don't need the line to be quite that long. Maybe 80 is about right. I would also say that the angle there is maybe a little high. I'm going to turn that down to 135. And let's see if that's a little bit more sloped. Yeah, there we go. That looks pretty reasonable. How does it look compared to this picture? It looks like I'm down a little bit too far. So that was done when I went forward 20 down here. I'm just going to go down 15 instead. Let's see if that makes it a little better. Just move the line up a little bit. Yeah, that looks better. Okay, so that got you a not equal sign. Now, as I mentioned back in our slides, I want you to realize that every single solution that I give you is not the only solution. There is always other ways you could have done this. There's no rule that said you have to draw that first line and then the second line. You could do this a lot of different ways and you would succeed in all of them. So don't feel like this is the only way to draw a not equal sign. It's just the way that happened to come to my mind. If you got a different solution and it worked, great. As a matter of fact, that's really great because it's nice to see other possibilities. So again, all of the answers are always going to be in the slides. We generally give you the answer so that if you're studying, you can go back and you can see it. But I promise you, you learn nothing by just flipping to the answer. You really do have to try that. I know you're hearing me and you're saying, I got it, I can read. But if you didn't actually try it yourself, the fact that I had to figure out how far down to come and what angle is correct, that is where I learned something. So make sure that you are trying the different things. So solution for the downward triangle, the upward triangle, the equal sign, and the not equal sign are all in here. Okay, so all of these have been lines. The next question that's probably popping into your head is, well, what happens if I need a circle? Well, how do you draw a circle? The answer is, with a turtle, you effectively have to tell it to draw a dot, and then move 1 degree, draw another dot, move 1 degree, draw another dot, and do that 360 times. So it would be something like this: t dot forward 1, t dot right 1, t dot forward 1, t dot right 1. So let's do that for just a couple of these so that we can see how that would look. I'm just going to erase all of this and go back to a blanker screen, t dot left 1. And what I'm going to do is I'm just going to copy and paste that a bunch of times. So copy, paste, paste. No, it would be great if I had an enter in there. Okay, apparently what I'm pasting is totally not what I thought I was pasting, so let's try that again. Highlight these two lines, copy, which I think I maybe forgot last time. There we go. All right, just pasting that a bunch of times. All right, so I'm going to hit run, and let's see what we get with the turtle. Okay, well, that's the beginning of a circle. It's kind of hard to see because I only did it. So if I paste it a bunch more times, like this, and then hit run, you'll see that I'll get a little bit more of the circle each time. And there it is. So I've built maybe a third of a circle, not a third, a fifth of a circle or a sixth. And if you kept doing that, you'd eventually get all the way around. You might wonder, why am I doing one for each of these? Well, that's technically how you get a circle. It will be 1 degree turns 360 times. You probably could get away with something that's a little bit more coarse. So I'm just going to erase all of this. And I'm going to show you that it, really when you started off drawing the square, and then we converted to the hexagon, and then the pentagon, and then eventually the hexagon. If you keep going down that path, you'll eventually get to a point where you're actually drawing a circle, right? So I'm going to do 4 and 4. I'm just going to paste those a bunch of times instead. That is not how you copy. That's how you copy. All right. don't know what's happening right now. It's not letting me paste. There we go. All right, and I need to press enter there. Okay, I'm going to run that again. And the only thing that changed here is that I moved 4 degrees each time. You can see I still got a pretty similar answer. And the reality is, at such a small size, it's really hard to see all of the detail of all 360 degrees. So quite often in computers, they're just going to take a shortcut here. And instead of going exactly 1 degree at a time, they're just going to move in increments of 4s or 10s or something like that. If we pop this out and we copy these guys and paste them a few times, I'll actually be able to get a circle drawn with just 36 of these instructions. And if we take a look at that, you can see I got a lot more of the circle drawn just by moving a lot further each time. And it still very much looks like a circle to the eye. My point here is your eye actually cannot really tell at that size whether it's perfect or not because it's all pixeled. So it doesn't really matter that it's exactly 1 pixel each time. It's just up to you as to how precise you want it drawn. The more precise, the slower it actually is going to be to draw. You're also going to have problems with the Artie robot if you try to make 1 degree turns because he's not quite that good. You're going to see that as we get there. But anyway, so this is how you draw a circle. You would effectively move right 1 degree and then go forward 1. Move right 1 degree, go forward 1, and keep doing that until you've gotten all 360 in there. The problem with that is in order to draw a circle, you would need 720 lines of code. 1 for the forward, 1 for the right. That's 2 lines, and then you'd have to do that 360 times. So that's a lot. It's a lot to type. You're probably going to make typos, and surely there has to be a better way. Well, what you're talking about here is something called repetition. You're asking the computer to do the same thing over and over again. And it turns out this is something computers excel at. Honestly, humans are terrible at it. If I ask you to take a piece of paper and draw 1,000 dots on the piece of paper, first off, you're going to lose track of how many dots you have, somewhere around 60 or 70, maybe long before then. And then secondly, you're going to do a terrible job at it. They're not going to be in a straight line. They're not going to be neat and tidy. The dots are going to be all of different sizes. We're just not very good at doing repetitive tasks, whereas computers are much better at doing that. So what we're going to do is we're going to write our first loop. This is a way to tell the computer I want to do the same thing over and over again, which is why it's called a loop. You're doing something in a loop. And the particular type of loop we're going to use here is called a while loop. This works both in the Artie robot and also in the Turtle graphics, so it's the same exact commands in both cases. So we're going to talk about loops in a lot more detail in a few weeks, but for now we're just going to go with it. So don't get too focused on the syntax here. We start off and we have the same import turtle and tturtle, that's always going to be there. But then I'm going to say I is equal to 1, I'll explain that in a moment, while I is less than 360, go forward 1, go right 1, and add 1 to the current value of I. Okay, so let's talk about what's happening here. I is called an index variable. It doesn't really matter. This is a detail you'll come to later. But effectively what I want you to think about is it's kind of like a storage space. You know how like you can have a locker if you go to a festival or you go to a concert or something like that? Sometimes they have lockers. And when you go to the locker, you can put something in the locker and lock it, and then you get the key. And then when you're done at the end of the day, you go back to the locker, you open it, and you take your thing back out of there, and the key usually stays in there. Well, a locker is kind of like a variable. A variable in this case has a name, and I can have more than one variable going on in my code at any given time. So here I have a variable called I, and I set that equal to 1. Why did I set it equal to 1? Because it's eventually going to make its way up to 360, and I need it to count. So I is equal to 1, and then I said while, that's a special keyword, while I is less than 360. Well, let's talk about that. 1 is less than 360. So because that's true, 1 is less than 360, it's going to do all the things in the while loop. And the things that it's told to do in the while loop is to move forward 1, turn right 1, and then add 1 to I. Okay, well, the third line in here is the interesting one. That's the one that's going to tell it to eventually stop. So we take I, which was originally 1, and when we add 1 to that, so 1 plus 1, that's going to be equal to 2, and we set I equal to 2 now. We then go back to the top of the loop, and it says, while 2 is less than 360, which it is, it moves forward and right 1. Then it adds 1 to it, I is now equal to 3, while 3 is less than 360. It is, so we move forward and right 1. While 4 is less than 360, while 5 is less than 360, while 6, 7, 8, 9, 10, 300, 310, 320, 350, 355, 356, 357, 358, 359. Okay, 359 is less than 360. So it draws one more dot and moves right one more time. It then adds 1 to it, which gets you to 360. While 360 is less than 360 is no longer true. Since it's no longer true, the loop is going to stop. So let me show you this in code, and let me see how this is a lot less code to write, but it accomplishes all the same things. So we're going to need these two lines, forward 1 and left 1, so I'm going to leave them in here. And the new lines we're going to add are I equals 1, while I is less than 360, colon. And then these two lines need to be moved over by a tab. This is very important. If you don't put the tab in there, they will not work. This is a Python specific syntax. And then I'm going to do I equals I plus 1. All right, so we're going to hit run here. And this is the same code that's in the slide. And what we should see is a circle. You will notice it takes it a moment to draw the circle because it's having to do that loop over and over again. So as you can see, that drew a circle for us. What would happen if we were to change some of the parameters? Like for example, this while, if I change that from 360 to 180, what do I get? Well, the loop is only going to go 180 times instead of going 360 times. So effectively, once it gets to the top here, it's just going to stop. And likewise, what would happen if I set that to 540? Well, it's going to do 540 cycles of the loop. And so that means it's going to draw the circle. Doesn't seem to be drawing right now. Let's start it again. Okay, something to be aware about with Replit is every now and again it'll get into a weird state, which is what's happening right now. It theoretically is running, but it's obviously not running. And even hitting stop and then run again doesn't seem to fix it. If that ever happens, usually what you want to do is just refresh the whole page. You can just safely just go click on the URL bar and hit refresh or hit enter, and you should get a brand new page and you should be able to still hit play in order to make it run. Okay, so that seems to have refreshed. Let me hit run and see if it works this time. Looks like it's going to. And so you can see it draws the first 90 and then the second 90. We're at about 180. We're at about 240. And we're almost back to 360 right there. But since I said 540, it's going to keep going until it gets to the top. And so that's a lesson to learn about loops. They'll keep going as long as you tell them to, whether it makes sense or not. I'm going to put this back to 360, and I'm going to change something else in the code. And I want you to think about what happens here. For example, see down here, I currently am doing I equals I plus 1. I'm just going to take that line completely out. What do you think is going to happen now when I hit run? So I is equal to 1. 1 is less than 360, so it goes forward 1 and left 1. I is still 1. 1 is still less than 360, so it goes forward 1 and left 1. I is still 1, still less than 360, so it's going to go forward 1 and left 1. As a matter of fact, I never changes. So this loop is going to keep going forever and ever and ever, and it's just going to keep going around and around in circles. As a matter of fact, if I were to leave this page open until the computer crashes on my side or theirs, that little turtle will keep drawing his circle, which isn't very helpful. So this is called an infinite loop, and it's something you have to be careful about. So each of those lines of code actually does mean something. It's important that inside the loop, the I variable actually changes, because if you don't change it, then the loop is always true and it'll keep going forever. The other thing to notice is I've now corrected it, but the circle is still going. Why is that? Well, because I've never restarted the program. Once you start the program, it's doing whatever code was there at the moment you hit start or run. It'll keep running that code until you hit stop, and now if you hit run again, it'll run the new code. So be careful about that you could be making changes that are not visible because, well, they haven't actually been loaded yet. So make sure that you always hit stop and run in order to see your new code. Okay, so we draw a circle by using a loop. In this case, we use a while loop, and there's going to be 3 additional lines that you need to be familiar with. You're going to have this I equal to 1, I less than 360, I equals I plus 1. That's how you're going to make a circle. Each of those things has a particular name. This I equal 1 is called a variable. The variable has a name. The name of the variable is I. Think of it like a storage place that can hold a number, and right now it's holding the number 1. It can only hold one number, so when you change it, the old number is lost. So it's like a locker that can hold exactly one thing, and it'll keep holding that until you put something new in there. The next line is while I is less than 360. This tells the program that we want to keep repeating the loop as long as I is less than 360. The t.forward 1 is the same as it's always been. It's what's telling the turtle to move forward 1 space. But I did put in capital letters here. Note there is a tab at the beginning of this line. Without the tab, you will get an error. Okay, I just want to prove this point. So this works and draws a circle right now. We've seen it do it before. Okay, again, I'm in a weird state where it's not actually working. Let me make sure I'm refreshed here. Okay, so why is that tab there, and what do I mean by tab? There's a button on your keyboard labeled tab, and what it does is it just moves your text over a little bit. If you're in a Word document and you hit tab, it will generally move you over a couple of spaces at the beginning of a paragraph. You tab indent the beginning of a paragraph sometimes. Well, Python requires that you tab indent anything that's inside of a while loop. All right, so just to prove a point that this works right now. All right, what am I doing wrong? While I is less than 360, I equals I plus... Oh, I typed I equals I plus I. That's not the same as I equals I plus 1. Okay, I think I've really confused things. All right, let's run that again. Let's see if it actually moves. There we go. All right, so this completely draws a circle, but I just want to show you what happens if I forget to indent these 3 lines. So instead of all 3 of these being indented, I'm just going to put them back to the way they were. The first thing to notice is that Replit went ahead and underlined this. And the reason it's underlining it is because it's identifying that this is an error, but let's hit run and let's just see what happens. The first thing to notice is that nothing over here actually draws. As a matter of fact, I don't even see the turtle this time. And the second thing to notice is this window, which up until now I've told you to ignore, and I'm just going to move my little video window, it now has a bunch of text in it, and it's really scary looking text. Python turtle on replit, traceback, most recent call last, file driver.py, line 26 in module blah blah blah, file frozen import libs, bootstrap external, line 800 in exec mode. All right, so there's a lot of stuff in here, and none of it seems to make a whole lot of sense to me. What's going on is you're getting an error from Python. Python does not like the fact that you have put this line of code here because it doesn't understand what's going on. The way that the computer understands that this is a loop is a couple of things. You use the word while, so it's like, okay, we're starting a loop. The colon at the end says everything below here is going to be part of the loop. And then everything that's in the loop is supposed to be indented. But since there's nothing indented, it's like, I don't know what you mean. This doesn't make any sense. Now, if I were to put one line indented, like for example, if I indent this first one and I hit run, I'll no longer have the error, but it will not do what I expect it to do. All right, so let's talk about what's going on. The only part that is looping is the part that's indented. And so the forward one is happening 360 times. And then at the very end, after it has done 360 forwards, it then turns left. If I want the left to be part of the loop, it also has to be indented. And likewise, I want the I equal I plus 1 to be part of the loop, it also has to be indented. And so now we're back to it'll draw a circle. So this is a syntax rule of Python, which is that anything inside a loop must be indented. It's a good practice in every language, even if it's not required by the language, because it makes the code easier to read. You can see that these lines are inside of there. So just something to be aware of, and that's why it's in bold in the slides, because if you had typed this in yourself, it's quite possible it didn't work, and most likely the reason it didn't work is because you forgot to indent. So remember to put the tab in there. All right, so the t forward and the t right are the same as they always were. And then the I equals I plus 1, this is the variable that you created at the top, and you're asking it to take the value that it was in there and add 1 to it. Eventually, when it gets to 360, the loop will stop. Okay, so figure out how to draw a smiley face like this, a semicircle starting here and going around to the left. It's a little tricky, and the reason is because the turtle initially starts off pointing to the right, which is not the way that you want to go. So you're going to probably have to turn the turtle around before you begin this process. So again, pause the video and figure out how to do this. Okay, so hopefully you've given that a try. And what you probably realized is that if you didn't do anything crazy and you just changed the loop to 180, you get a semicircle. I already demonstrated that a few minutes ago. This gives you a C, effectively, that's backwards. So that's almost right, but the problem is I want to rotate it so that it's no longer a C, it's a smiley face. And that means before I start the loop, what I need to do is I need to turn the turtle to the right by 90 degrees. So now, when I start the process, it's no longer pointing up, it's pointing down. And then I get a smiley face. And I could certainly have this draw either way. That's just the difference between the left and the right down here. If I do right, it's going to draw it the exact way where the arrow is pointing to the other side, like it was in this slide. So the important part was you have to figure out to turn the turtle to the right before you begin the circle. And that's another thought here is the order of these statements is very important. That right turn, if you put it in the wrong spot, it doesn't really work. All right. So what were the steps that we're using to solve these more complex shapes? Well, it's to use abstraction, the same thing that we talked about in the last lecture. Focus on the task that you're trying to get done, brush away all the unnecessary details, and try to solve the most basic part that you can. Solve that part and then just experiment to figure out the more complex parts. As I said, when I was coming up with these slides, many of these drawings I did not get on my first attempt. The equal sign was actually about 10 attempts before I got it right. I just had to keep playing with it until I got it right. So if you're finding that you're having to do this a bunch of times as well, that doesn't mean that you're doing it wrong. That's exactly what's supposed to happen. It'll take you a few tries to get it right. So don't be afraid. You're not going to break anything by trying. So just try it and see if you can figure it out and then go from there. All right. So we've talked a lot about the turtle graphics. And I've mentioned before our little friend, the robot Artie here, but we haven't actually looked at him at all to see how to program him. And so we're going to talk just a moment about doing the exact same things that we've done with the robot using Artie. So the first thing we have to talk about is how to set him up. And then we're going to talk about how to program him. He understands the same 5 commands that we have on the turtle graphics, but we first have to get him set up. So step 1 is Artie needs batteries. If you notice, there's a couple of parts of Artie. The first part is this blue bit opens up on the top, and there's a, it may be inside there, it may be somewhere separate. There's a little plastic cap that comes with Artie, and that is a super important piece. You're going to need that. I generally store it in the top so it doesn't get lost. But the inside of there, in his little head, you'll see that there is a on-off switch, which right now is off, and when you flip it on, it turns on a little red light in there. So that's how you can tell whether he's currently on or off. The other thing is, Artie has a set of batteries. And that's done through his back panel. So right here on his back, you can see that there's a screw hole there. And when you pop that open, he takes 4 AA batteries inside of that little pouch on his back. So if you have a robot that's not turning on, it's most likely that your batteries are dead and you need to bring that to us so that we can take a look at it. All right, so once you've got the batteries in there and you've got them turned on, the next thing you need to do is you need to put a pen into it. Each of the Arties should have come with a couple of pens that say Artie on them, and they say that they are washable, which is probably important because he's going to do some crazy things. So what you're going to do is remove the lid off the pen, and then in his head there is a small hole, and what you're going to want to do is you're going to want to start pushing the pen into that hole so that it goes down in the hole of the head. And if you were to push it through hard enough, you'll notice that it'll eventually pop out of the bottom. All right, but you don't want to go all the way through. So as a matter of fact, what I'm going to do is I'm going to take that little plastic piece that we talked about earlier, this guy, and you'll notice that there's a raised edge on one side. I'm going to put that raised edge up so that it connects to the bottom of the Artie. All right, and now I'm going to push the pen in from the top all the way until the tip of the pen reaches the plastic bottom. You don't want to go past that point, so you need it so that the pen is sticking out just barely out at the bottom. This takes a few times to get right, because if the pen is not in far enough when Artie draws, he won't actually draw anything, and if it's in too far when Artie draws, he will leave scooch marks everywhere he goes. So it's important that the pen is in exactly the right amount, and that's what this plastic cap does. It tells you whether you got it right or not. If you can place the cap on and you push on the pen and you can feel it on the cap, you got the right amount in. All right, so once you've got the cap on and you have turned the robot on, the next step is you're going to want to connect to the robot. And what happens here is Artie puts out his own little Wi-Fi network. And very specifically, if on my little machine here, I'm to pull up all the Wi-Fi networks, and I come in here, you will see there will be a network called Artie dash something. Your Artie name may be different. In this case, it's Artie-DE99. And so this Artie name is actually the Wi-Fi network for this guy. And so all you got to do is you've got to connect to that Wi-Fi network. And once you connect to it, you'll be able to go to a URL in a browser called local.codewithartie.com. And when you type that in, you'll be on the Artie control panel that looks like this. And then inside of here, you can type your Artie commands. And when you're ready for him to move, you hit run and he'll actually go draw. I'm going to post a separate video where I've already had Artie go draw a smiley face, so that you can see what Artie is doing, and it's linked right here in the slides. If I come back over to the slides, it is important to say that the Artie Wi-Fi network is safe to connect to. It's only going to allow you to talk to the Artie. You can't get anywhere else while you're on the Artie network. So again, in your browser, you type local.codewithartie.com, and then once you get in there, there's this button up at the top with these 4 dots. You're going to click that and choose Python as your language. Artie actually supports a couple of different languages, and you can program in different ones. When you get to Python, it's going to look something like this. And just to orient you, this is the window where you're going to type your code. This is an output window that shows you what Artie would do if you're in simulate mode. The simulate button is up here. So the difference is in simulate mode, the robot doesn't actually move. It just draws what the robot would do in a window. When you turn off simulate and hit run, the robot actually moves and does what you're telling it to. So this allows you to practice until you get it right and then have Artie actually draw it. I will warn you that once you actually have him drawing, you will find that he'll start like going off the edge of paper and drawing random lines on tables and floors and places you're not supposed to be drawing lines. So you might want to practice a lot with the simulate button on before you turn the robot actually loose. But anyway, this is where you write your code. This is your run button. This is the simulate or don't simulate button, and if you're simulating, this is where you see the output. When you hit run, the robot will execute the Python commands, and you'll get to see what's happening in real time. So the code for coding with Artie, it's going to be artie.pen down, artie.pen up, artie.left, artie.right, artie.forward, and he also supports artie.back, which is different than the turtle. The turtle doesn't directly support back. In the turtle, it was T dot instead of Artie dot, but it's the same thing other than that. All the commands are the same. So what I want you to do, and you can do this in your simulator, or if you're playing with an Artie, I want you to figure out how to make a smiley face. So a smiley face is a circle, and inside the circle you've got two eyes, a nose, and a mouth, which is a semicircle. So you're going to have to think through how you would do that, break it down into its individual parts, figure out how to draw the circle, figure out how to add in the lines for the nose and the eyes, and then figure out how to draw a semicircle. And there's going to be a certain amount of moving around that'll teach you how much you're going to have to get out, to move from one place to another after you've done the nose, to draw the eyes, and so on. For the eyes, I just mean two individual straight lines. I can show you my beautiful version of Artie's smiley face. This is where I ended up. You might wonder what happened with the mouth. Well, I think he's up to something, is what happened. You might also wonder what happened right here, and I think he has a zit. But that's actually just my pen was down a little too far when I started, and so it left an impression in the middle before he began. And there's another dot down here when I had lifted him up and placed him down. So just kind of be careful with that. The other thing you might notice about my drawing is that it's not perfect. The robot, he's a very special little guy. Sometimes he will move in unpredictable ways. Sometimes these little wheels lose traction, and so he won't fully make the turn that he was trying to make. The other thing that sometimes happens is he ends up scooching the paper. So I actually had to tape down this paper in order to get him to draw the face. And if I'm being honest, this was, I think, the fourth or fifth attempt of me recording the video of him actually working, which is why I went with this one, because I had lost the will to live by the time I got this one working, even though it's still not perfect. So just bear in mind that he's not perfect. He has his issues. We all have our issues, let's be honest. And he's still entertaining to play with. So there's the video of Artie drawing a smiley face. I'll let you click that and watch it yourself. Remember, as I say, precision is not always the most important thing. I will point this out. When I was drawing the circle, these are not 1 degree turns. If you actually stare at the circle a little bit up close, you can kind of see what I did there. Each time the pen is a little bit tighter, what you're noticing is that I actually did, it was, I think, 4 or 5 degrees each time, as opposed to 1 degree. And it's simply because poor little Artie can't accurately make 1 degree turns. So if you do 1 degree turns, you won't end up with a full picture. And that's actually what happened with the mouth. This is supposedly 180 1 degree turns. Well, you can see he didn't quite make all of them. So that's why we ended up with a semi-smirk. The other thing to notice is that Artie just takes a moment to move. It's kind of entertaining to watch and somewhat relaxing, I guess, because, well, he's just soothingly going off and drawing his stuff. But it's not as quick as you might think it is. And that's true of most robots. And the final statement I'll make is that things often make sense in your head and in the simulator. And then when you actually do them in the real world, where you have like a robot execute them, you often realize that the real world is a lot more complex than you would have thought. Things can happen. Like my table was not completely even. And you wouldn't really think about that when you're programming it, but it does make a difference when he's making turns left or right. He tends to favor whichever way the table is sloped. And you can bump the table when you're walking around it with a camera, and there's all kinds of things that can go wrong. So just be aware of that. The final thought is, if you watch the video, you'll see there's one moment where I make a completely unnecessary turn. And it succeeded. It got me the picture that I wanted, but it's not exactly right. So that's okay. It doesn't mean that it's wrong. It just means that, it is what it is. This is the solution to the smiley face, in case you need to go back and look at that. And then the final notes that I'm going to make about Python in general. At the top of the file, in both the turtle graphics and in the Artie, there were 2 lines that were added in both. In the turtle graphics, it was import turtle, and then t equals turtle turtle. In the Artie, it says from Artie, import Artie, and then Artie equals Artie. And you might wonder what those 2 lines do in both cases. The short version is, we're not going to worry about it. Not really something that we're going to cover in this class. If you continue on and you take 1321, you'll learn about it at the end of 1321, and the answer is they're related to object-oriented programming. The details of all that, we'll get to it later. They just have to be there and they have to be typed exactly as they are. Capitalization matters, spacing matters, parentheses matters, so be sure that you put everything in exactly as it's supposed to. All right, so in Module 3, we learned about problem solving, which is a very important life skill. You will need it not only in this class and on our tests and in the final and all that, but you'll need it in your life, your other classes, your personal life, and even your career. So, problem solving is definitely something to work on and continue working on. The more you do it, the easier it will get for you. The key is to keep trying, don't give up. You will get there unless you give up, and there is no magic. There's no magical way that you're going to just do it faster. The only answer is keep trying. Some people will get one problem very quickly. The fact that you didn't doesn't mean that you're not smart or that you're never going to be able to figure things out. It just means that that particular thing made sense to them. The next problem, you'll probably get it faster than they will. So that's it for computational thinking. I will see you guys in the next section, and take care.